We will extend the problem. Instead of knowing the if you know any of two sides or any one angle, then how to evaluate or how to find out the rest of the trigonometric ratios, right? Now this is the problem. After knowing the value of a specific trigonometric ratio, we have to prove a particular identity from the known values. So this is a simple extension for the previous problem. So let me take a right angle triangle ABC. Now here it is a chord A, so therefore I will change the notation. It is A, B, C. So I will put like this. So that is a small change. Now what is given? So chord A is equal to 4 by 3. So chord is nothing but adjacent side by opposite side. So for A, the opposite side is 3 and adjacent side is 4. So like a similar previous problem, we know the two sides. So hypotenuse is 4 square plus 3 square under root. So therefore it is 5. Now for this right angle triangle, I know the opposite side is 3 and adjacent side is 4 and hypotenuse is 5. So three sides I know. So I can find out any of the trigonometric ratio. Now we have to prove this identity. So therefore what happens? So I have to find out the value of tan A and I have to find out the value of cos A as well as sin A. So I will write the sin A. Sin A is equal to opposite side, which is 3 by hypotenuse is 5. Cos A is nothing but adjacent side 4 by 5 and tan A is nothing but 1 by cot. So directly I can write 3 by 4. Now with the help of this, so I will take the LHS side of the identity. LHS side of the 1 minus tan square A. So the tan is 3 by 4 square by 1 plus tan square, which is 1 minus 9 by 16 and 1 plus 9 by 16. So if I evaluate 16 minus 9 by 16 plus 9, so which is nothing but 16 minus 9, so the value will be 7 by 25. Now take the RHS side of the problem. Cos square, which is 4 by 5 whole square, minus sin square, which is 3 by 5 whole square, which is 16 minus 9 by 25, which is also 7 by 25. So both are there. So therefore the identity is valid. So this is the extension after knowing the trigonometric ratios. If you know the trigonometric ratios, then you can prove any trigonometric identity from the values. Now, for example, if this question asks, instead of giving the angle, instead of giving this angle, if the same question is uh, provided, then see, now for the same question I will change the way of asking. Prove the trigonometric identity. Now we have to take the LHS and we have to show the RHS. Now very simple change in the question, right? Now see, take the LHS side of the problem. 1 minus tan square A by 1 plus tan square. So before doing some, before applying some operations on this particular trigonometric expression, observe the right hand side. So consisting of cos and sin. So therefore, first you have to convert the tan angle into cos and sin ratios, cos and sin expression. So 1 minus tan is nothing but sin by cos. So already we expressed The tan A is equal to sin A by cos A, so whole square by 1 plus sin A by cos A whole square. Now see this. So which is cos square A minus sin square A by cos square A. So this is what the numerator. For denominator, after taking the LCM, cos square A, sin square A by cos square A. So cos square gets cancelled and sin square plus cos square is equal to 1. So already we proved this identity. So obviously the answer will be cos square A minus sin square. So the same question, only instead of giving the angle, we have to show the identity because the identity have LHS and RHS. So therefore you have to start from LHS and we have to prove the RHS. This is another way to solve the problem. Now, for example, so if you want to solve the problem conventionally in descriptive manner, we can follow these two methods. For example, if this problem is given in competitive exams, then how to evaluate or how in competitive exams this problem will appear. Now I will change that. In case of problems, in case of competitive exams, now what happens? The question will be, we don't have all this. Just the question will be 1 minus tan square A by 1 plus tan square A is equal to. Now we have the options. A is equal to cos square A minus sin A. B is equal to cos square A plus sin A. C is equal to cos A minus sin square A. D is equal to cos square A minus sin square. Now this will be the question may ask may appear in competitive exams. Now you don't have the value of the any of trigonometric ratio, and you don't know the clue how to convert the given expression, whether the tan should be converted into cos, because somewhere here you may have cosecant. Now you will get the doubt that so whether have to convert the sine terms, tan terms into sine and cosine terms, or maybe in other terms, right? So therefore, so if you want to solve this problem, generally we will take the LHS side of the equation and we will reduce and we will verify whether the reduced expression is available in the options or not, right? So now, for example, if you know a particular value of tan A may be 0 or A may be 30 degrees or A may be 45 degrees or A may be 60 degrees or A may be 90 degrees. If you know that, then what happens? So automatically you can find out this expression by substituting any of the trigonometric value. For example, if I know tan A is equal to some A, small a, or tan A is equal to some P, then it is 1 minus P square by 1 plus P square. P is a numerical value. So therefore, I will get one numerical value for this expression. If you substitute the same in the options, so I may get the similar value in the option, so that I can find out the correct option after knowing the tan A value. So therefore, we need to identify some fixed angles. So if you identify some fixed angles for trigonometric ratios, then automatically majority of the competitive questions related to the trigonometry can be solved without doing much computations. So that will be discussed in the part 7.